Good morning, my name is JT and today I will be discussing orbiting fuel depot. More specifically, first I will introduce the main advantages of orbiting fuel depot. Then I will discuss the limiting technologies. I will introduce a brief example, and then finally we will go over the current work that is being done on orbiting fuel depot. So the main advantages of orbiting fuel depot, the first one, which really might be the most significant, is that orbiting fuel depot would enable deep space missions and interplanetary travel. So this could allow to have lighter spacecraft on the launch pad or have spacecraft with more payload. They would meet with an orbiting fuel depot either in LEO, GEO, or Earth and Moon Lagrange points 1 and 2, depending on the mission profile. There they would refuel the spacecraft, and then it would have a much extended range in order to reach further space destinations. The second advantage would be the potential number of customers. So we're not only talking about national space agencies, NASA or other countries, we're also talking about the private industry. So the Delta, the Atlas, the Falcon, they all have liquid propellants, and they would be interested in being able to refuel liquid hydrogen, oxygen, or RP1 on orbit. The third advantage would be the ability to refuel current satellites on orbit. Instead of deorbiting them at the end of their life cycle, we could extend their lifetime by as much as 8 years. And then finally, the orbiting fuel depot would really promote a great space economy where private industries could focus on developing and building some cheap and light spacecrafts with the sole purpose of delivering liquid propellants on orbit. So why don't we have those orbiting fuel depot yet? There are several limiting technologies. I've listed the main ones, but there are many more. And really, the most challenging part comes from the cryogenic property of those propellants. Their boil-off temperature is extremely low, so it's very challenging to keep them cool in space when the orbiting fuel depot is exposed to the sun. And not only the tank itself needs to be insulated, but also the transfer lines in between the depot and the spacecraft being refilled. Let's imagine that an orbiting depot would be orbiting for 6 months in between 2 refills. This has the potential of a tremendous amount of waste in terms of boil-off, several metric tons at $10,000 per kilogram. It's a very big amount of money being wasted. The second challenge comes from the microgravity environment. The propellant is not settling inside the tank, so it's difficult to know how much propellant is in there. It's also challenging to refill the tank itself. Whenever the tank is being refilled and the pressure builds up inside, venting causes problems and has the potential of waste as well. And then finally, the orbiting depot being in space, it needs to be self-sustainable against MMODs. So there are still some other limiting technologies that are not listed here. These are just the main ones. Let's look at a brief example. This was proposed a few years ago. This architecture is based on current understood technologies from ULA. This project was proposed for the NASA ESAS exploration architecture, and it had the potential, it was shown that it had the potential to save as much as 80 metric tons of LO2 on the launch pad. So this specific design focused only on LO2, not LH2. And this was enabling the spacecraft to carry as much as 183% of payload to the moon. Unfortunately, that specific project didn't go through. So what current work is being done right now on orbiting fuel depot? NASA has been working on it since the beginning. The current project is the Cryogenic Propellant Storage and Transfer project that aims at developing those limiting technologies we just discussed. SpaceX has some grand plans of deep space travel and interplanetary travel. That includes some orbiting fuel depot, and there's a picture of it, a picture of that tanker. ULA is also currently developing a new tanker, and most recently the Chinese National Space Agency has connected the first satellite-to-satellite refuel in 2016. So there is definitely some interest in developing some orbiting fuel depot. It's probably one of the missing key elements to enable mankind for deep space travel and interplanetary travel. Thank you.